Hi, everyone, and welcome back to Dave's Math Channel. I'm your host, David Tare, and today I'll discuss the mathematics of gambling. So let's begin. So, what is gambling? Gambling is betting against opponents on a set of possible outcomes, at least one of which will occur with certainty sometime in the near future. As such, gambling includes games of chance, such as those offered at casinos like slots, roulette, craps, blackjack, and poker. But there are other forms of gambling as well, such as various types of investments. Although we usually think of gambling as playing games for money, and we don't usually think of investments as a game, when you get right down to it, it is, and all other forms of gambling are as well. Gambling can be divided into two types: games of chance and games of skill. Games of chance are those games over which the players have no control over the possible outcomes, since these outcomes are completely random. Most casino games, like slots, roulette, and craps, are games of chance. As we will see, if you play these games enough, you are guaranteed to lose money. However, it may be possible to win at various games of skill, such as blackjack and poker, by using the right strategy. In addition, many forms of investment, whether or not they involve skill, are likely to earn you money in the long run. We first consider games of chance, since these are easier to analyze. Let's start with a very simple example, namely coin tossing. Suppose you play the following game with a friend. Your friend has a fair coin which you need to try to guess ahead of time whether it will land on heads or tails. First you guess and say either heads or tails. Next, your friend tosses the coin, which lands on either heads or tails. Each time you guess correctly, you win $1, and your friend loses $1, and vice versa if you guess incorrectly. The payoff matrix, shown below, sums up the situation for each toss. For a single game, the rows of the matrix correspond to your guess, and the columns correspond to the outcome. The first number of each pair of each entry indicates the winnings or losings of both you and your friend, respectively, after each toss. An important concept in analyzing games of chance is that of expected value, abbreviated as EV. Expected value of a bet made in a game of chance is the expected amount of money you will win or lose if you play the game once. In the previous example, since the coin is fair, the probability that you guess the outcome of each coin toss correctly is 1/2, which means that in the long run, half of your guesses will be correct and the other half will be incorrect. Once your average net winnings per game will be equal to 0, so the EV of a single game is equal to 0. What this means is you could get lucky in the short term, and it's likely that you will win and your friend will lose, since this is a zero-sum game, or vice versa. But if you play long enough, your luck against your friend will tend to average out, so that no matter how long you play, neither of you can be assured of continuing your winnings or losing streaks. There's a nice formula for computing the EV of any game of chance with two possible outcomes corresponding to winning or losing. Let P be the probability of winning and Q, which is equal to 1 minus P, probability of losing such a game. And let capital W denote the amount of money you would make if you win, and let capital L denote the amount of money you would lose if you lost. And the EV of the game is given by the following equation. Equation 1, which says the EV is equal to P times capital W minus Q times capital L. So now I'm going to talk about fair and unfair games. Games of chance with an EV of 0 are called fair games, and those with a non-zero EV are called unfair games. The example of coin tossing given in the previous slide is an example of a fair game. However, considering the following example of coin tossing with the following payoff matrix, which you can see is different from the previous one. So let's calculate your EV per game in this case. Since the coin is still fair, the probability of your guessing correctly or incorrectly are still both equal to 1/2. However, now if you win, you only win $1, but if you lose $2. Thus, in this case, from equation 1, the following calculation shows your EV per game. So using the formula, we see that EV is P times capital W minus Q times capital L, which is a half times $1 plus a half times minus $2, which is 50 cents minus $1 or negative 50 cents. What this means is that each time you play this game with your friend, you can expect to lose 50 cents. Furthermore, since this is a zero-sum game, your friend can expect to win 50 cents. This game is clearly unfair. So now I'm going to talk about casino games of chance. As in the previous example, all casino games of chance have a negative EV for the players. Once if you play any of them long enough, you're guaranteed to lose money, which is how casinos earn their money from gambling. Your expected losings per game for slots vary from machine to machine and from casino to casino, but for most slots, the EV for every dollar you spend is about 2 or 3 cents. As we'll see, the fairest casino games of chance is craps, a popular dice game. Roulette is another popular game of chance offered at most casinos. It's straightforward to compute your expected losings per game for each of these games, so we'll do this next. The commonly used term in casino games is odds. Although the term odds usually refers to probability, in casinos they refer to payoff. For instance, a casino game of chance with capital W equal to K times capital B and capital L equal to capital B is said to have odds of K to 1. More generally, it is said to have odds of W to L. However, the probability of winning these games is less than these odds indicate, which is once again due to the house advantage. Craps is a popular dice game offered at most casinos. A picture of a craps table with a game in progress is shown below. So now I'm going to talk about the rules of craps. The game of craps is played with 2 fair 6-sided dice, with each face of each die numbered from 1 to 6 as indicated by the number of spots, also known as pips, on each face. The game of craps consists of a series of turns, at the beginning of which both dice are rolled. However, before any dice are rolled, each player must place a bet for the game. There are 2 possible outcomes of a game of craps, winning or losing. If a player wins, he earns the amount of money equal to his bet, but if he loses the amount of money he put down. Specifically, if a player has bet the amount of money B, then W equals L equals B. After the first roll, the player wins if the sum of the dice on his turn is either 7 or 11, and he loses if the sum is either 2, 3, or 12. In every other case, i.e. 4, 5, 6, 8, 9, or 10, the sum is known as the player's point, and the game continues with a series of turns until the player either rolls his point, in which case he wins, or he rolls a 7, in which case he loses. Although the analysis is rather complicated, it turns out that the probability of winning a game of craps is P equals 244 over 495, approximately 49.3%, once the probability of losing is Q equals 1 minus P, which is equal to 251 over 495, approximately 50.7%. So now let's calculate the EV of craps. So what is the EV of a game of craps? Suppose you bet $1 on a game of craps. In this case, we also have W equals L equals B equals $1. So by equation 1, we have EV equals P times capital W minus Q times capital L, which is 244 over 495 times $1 minus 251 over 495 times $1, which turns out to be minus 7 over $495 or approximately 1.4 cents. So that means that for every dollar you bet on craps, you can expect to lose approximately 1.4 cents. So next I'm going to talk about roulette. Roulette is another popular casino game of chance. A typical American roulette setup is shown below. European roulette is similar, except that the roulette wheel shown here on the left has 37 slots rather than 38, since there's no 00 slot, as there is in American roulette. So now I'm going to explain the rules of American roulette. So to play a game of American roulette, one first bets money on any set of the following possible outcomes. So you can bet on a single number. To do so, you just place money on any of one of the 38 small squares on the table, and the payoff for such a bet is 35 to 1. Or you can bet on a group of 2, 3, 4, or 6 numbers. And to do so, you just spread your bills across any 2, 3, 4, 6 squares on the table. The payoff for each of these bets are 17 to 1, 11 to 1, 8 to 1, and 5 to 1, respectively. Or you can bet on a group of 12 numbers as indicated on the board, i.e. 1 through 12, 13 to 24, 25 to 36, or any of the 3 columns. To do so, you just place your money on any of these tabs to these groups, and the payoff for any such bet is 2 to 1. Or you can bet on green, which is 0 or double 0. To do so, you spread your money across the 0 and double 0 tabs. The payoff for this bet is 17 to 1. Or you can bet on red or black. The payoff for each of these bets is 1 to 1. Or finally, you can bet on low, 1 to 18, or high, 19 to 36. Once again, the payoff for each of these bets is 1 to 1. So once all the bets are placed, the host spins the roulette wheel, shown on the left, and releases the metal ball, which lands on the rim of the wheel, when it spins for a while in the opposite direction, and eventually stops spinning and falls into one of the 38 slots, namely 0, double 0, 1 to 36. Finally, each player is paid off as indicated above. So now let's calculate the EV of roulette. So suppose you make a single one-to-one bet of $1 on a single game of roulette, i.e. you bet on red, black, low, or high. What's your EV? In this case, capital W equals capital L equals capital B equals $1. Since the roulette wheel has 38 slots, 18 of which corresponds to your winning, and the other 20 to your losing, we have P equals 18 over 38, or 9 over 19. Q equals 20 over 38, or 10 over 19. So by equation 1, we have EV equals P times capital W minus Q times capital L, which is 9/19 times $1 minus 10/19 times $1, which is negative 1/19 of $1, or negative 5.3 cents approximately. This means that for every dollar you spend playing roulette with this strategy, you expect to lose approximately 5.3 cents. As it turns out, this is also the case no matter how you bet. So now I'm going to talk about casino games of skill. So in addition to games of chance, most casinos also offer various games of skill. These include various card games such as blackjack and poker, shown below. Since these games involve skill as well as luck, if you're skillful enough at these games, it is possible to earn money in the long run by playing them. We briefly describe each of these games in what follows. So blackjack, also known as 21, is a card game in which each player is first dealt 2 cards face down from a shuffled deck. After anteing up, i.e. making a standard initial bet, each player then looks at their cards and adds up their face values, with royals, i.e. jack, queen, or king, worth 10 points, and aces worth either 1 or 11 points. Then each player tells the dealer if they want to hit or stay. If they say hit, they are dealt another card. If they go over 21, they lose, go bust. But if not, they're given additional chances to hit or stay, and play proceeds as in the first round until they stay or go bust. Finally, once all remaining players say stay, they all reveal their cards, and the winner is the player with the highest score. In addition, a combination of an ace and any royal is known as a blackjack. So if a player gets this at the beginning of the game, he says blackjack, which is an automatic win. So there's an important skill in blackjack known as counting. Counting is a very difficult mathematical skill to learn, but those who know this skill can make lots of money by playing with this strategy. Counting involves keeping track of the number of high cards and low cards that have already been dealt from the deck once it has been shuffled. In the simplest form of counting, the dealer uses a single standard 52 card deck, and as the game proceeds, counters keep track of a count, which is based on the number of high cards, typically aces given a count of 4, and royals given a count of 3 each, and low cards, 2 through 9, given a count of -2 each. If the count during the game is greater than 0, then the deck has an excess of low cards, while if it has a count less than 0, it has an excess of high cards. And counters can use this information to their advantage during the rest of the game. Since the above counting strategy is pretty easy to learn, casinos have made it much harder to count by shuffling together more than just one deck. Typically 6 are now used. In addition, if a casino knows of a counter, which they're pretty good at spotting these days, they will not allow them to play. In fact, they may even hire violent thugs to go after them. So counting is a very risky business. So now I'm going to talk about poker. Poker is another very popular gambling game involving skill, also offered at most casinos. There are many versions of poker, including 5-card draw, 7-card stud, Omaha, and various forms of Texas Hold'em. A common feature of all forms of poker is that they all involve betting as well as achieving one of a set of ranked poker hands. The remaining player with the highest hand winning the pot, i.e. all the money put into the table, are the other players during the hand, and the other players losing the money that they put into the pot. Although it's very difficult to win consistently in any form of poker, there are a handful of poker sharks who can, a few of whom have made millions doing so. Poker skill involves both math and psychology. Math comes into play in estimating the probabilities of achieving various possible winning hands, while psychology comes into play in other ways, such as outbluffing your opponents and reading tells, such as poker faces and other known habits of other players depending on their concealed cards. Finally, I'm going to talk about investing. As I mentioned at the beginning of this video, investing can be regarded as a form of gambling. However, an important difference between gambling at casinos and making smart investments with a good strategy is that whereas gambling typically involves a negative EV, most forms of good investments inherently involve a positive EV, so that even if you don't really know what you're doing, you can still expect to make money by investing. For instance, during a typical year, the value of most stocks grow by about 8 to 10%. So even if you choose to invest in, say, $10,000 in 10 randomly chosen stocks on the New York Stock Exchange, you can expect to earn around $800 to $1,000 after 1 year. In addition, if you're smart, you can gain several valuable insights into what constitute good investments, so you can expect to make considerably more money. However, keep in mind that investing is still gambling, so you could also lose money. And in fact, even the best investors in the world often do. But if and when you do, you shouldn't get discouraged, because if you continue, you can expect to make it back. Also, keep in mind that it only makes sense to invest if you have some extra savings with which to do so. In other words, don't blow your money you need for essentials, such as the basic needs of you and your dependents, on investments. Thank you for watching, and I'll see you next time.